This is the most unlikable place on Earth, a desert that is almost empty of human life. But still, a great example of engineering is being made here, which is no less than a wonder in itself. In the middle of the Atacama Desert in Chile, on the peak of the mountain 10,000 feet high from the sea, the construction of the world's largest telescope is underway. When this 40% higher telescope is completed than the Leaning Tower of Pisa, it will be able to see the planets far away from our universe 5,200 times closer than our eyes. And these images will be 15 times sharper than Hubble Space Telescope. But making the largest telescope in the world at the driest place on Earth is no less than a miracle. After the Atacama Desert and Antarctica, it is the driest area in the world, where some parts are found where there has never been a single rain in history. How will this telescope go back in time to see the first galaxies, stars, and planets of the universe? How can this telescope help scientists in finding other planets like Earth? And most importantly, scientists and construction team had to face many difficulties during construction of a football field as big as the dome. Viewers, this is Atacama Desert in Chile, 1,000 kilometers from the Pacific Ocean front of South America. After Antarctica, it is considered the driest place in the world. Here, nature has such unique colors that we are seeing for the first time. Here, the Cholamuki is found in large numbers. In addition, the Death Valley, the desert spread over thousands of square kilometers filled with salt, and the fog of Dund, which is rare all over the world. But one thing that is most important for life is not found here: water. Atacama Desert's landscape is such that it does not rain here. There are even some areas that have not seen a single drop in history. Atacama Desert presents the view of an alien planet on these specialties. And maybe that's why the European Space Agency did its Mars rover testing here. This extraordinary project is under construction at a distance of 1,300 kilometers from the capital of Chile, Santiago, and 130 kilometers from the city. This extraordinary project is under construction at a height of 10,000 feet above sea level, which will give humanity a chance to see the other world in space. The European Southern Observatory, also known as ESO, is building a huge telescope on this spot, which is called Extremely Large Telescope, or E-ELT in short. Although its construction is not complete yet, but it will not be difficult to guess why this name has been given. A very large mirror will be installed in this telescope, whose diameter is not only 39 meters, but will be 4 times larger than the largest telescope so far. This mirror can surprisingly collect 10 crore times more light than human eyes. But the condition is that a drop of soil should not fall on it. To avoid this, the telescope will be covered with a very large steel dome, which weighs about 2,400 pickup trucks, almost 6,000 tons. 2 very large doors will be installed on this dome, which will be closed during the day. This dome is so tall that a Statue of Liberty can also stand inside it. And if we talk about the spread, a football field can also be made inside it. Below this is a high-tech platform that makes the entire telescope capable of rotating 360 degrees, so that it is easy to see any part of the sky at night. It is worth thinking that in this deserted area of the world, where there is no population around, how the construction team started this project. Especially where there were no roads, no electricity, no water, and on top of that, construction was on the top of the mountain. For this project, ESO first explored many places in Europe, but in the end, they had to choose this location in South America. ESO is a government organization in Europe, which has 16 members. ESO's project head says that there are many reasons behind selecting this place for E-ELT. First of all, they wanted a place for the telescope where there is no city far away. The reason for this is light pollution. You must have seen that at night, there is often light on the cities. And if there are clouds above, they are also clearly visible. This light is far more than the light of a star thousands of light years away, which can spoil the image generated from the telescope. But many such locations are present in the mountains in Europe. So why was this location of South America chosen? It is not enough to save E-ELT from only light pollution. It is also very important to have clean sky. In Europe, most of the time, there is tropical weather, which is why there are often clouds here. But the Atacama Desert, because it is one of the driest parts of the world, that is why there are no clouds for 320 days out of 365 days of the year, which is very important to see the galaxies far away. In 2010, the team of ESO tested at different places and finally found the best location of the Atacama Desert, 3,000 meters high mountain, which is called Cerro Amazonas. But the problem was that it was quite a steep mountain like other mountains. It is not possible to construct any kind of construction on it in this condition. Therefore, it was very important to cut the top of this mountain and straighten the area as big as the 7 football fields. Imagine that the 3,000-meter-high Nauquila mountain and a very large field above it. It was very difficult and dangerous to do this with the help of excavators. Therefore, in 2014, the construction team got the help of explosives. Explosives were put on the top of the mountain, and they were torn apart by remote controllers. In this process, the upper part of the mountain was blown up. It contained 47 lakh cubic meters of soil. This was so much soil that 1,911 Olympic-sized swimming pools can be filled. After removing the soil and stones, the upper part was straightened, and a path was made to reach the top. But this was just the beginning. 7 football fields were built as straight as the ground on the mountain, but a very big problem came up. A problem that stopped the construction of E-ELT for the next 5 years. The engineering team saw that sinkholes were being made at the top of the mountain. They would fill them up again, but after a while, many spots would get buried. This was the biggest problem in the way of putting the foundation of E-ELT. The explosives that were put on top of the mountain had caused a lot of damage to the core of the mountain. Cracks were formed in the rocks and the soil started to get buried. After every few months, the rocks would have movement inside and new sinkholes would be formed. To tackle this problem, engineers drilled many holes in the ground and artificially stabile the ground with the help of vibration so that all the sinkholes can be made at once. Finally, the vibration method worked, and the top of the mountain was once again planned by filling the sinkholes. It took the next 5 years to complete this process, and now the next step was to put the foundation of E-ELT. This was not an ordinary foundation. This part of Atacama Desert is a seismically active region where earthquakes are very common. To save the expensive parts of the telescope from earthquakes, the foundation was kept separate from the dome above. Many hydraulic shock absorbers have been installed between the foundation and the dome, which prevent the earthquakes from reaching the metal dome and the telescope mirror inside it. In 2023, the foundation work was completed, and now it was time for the amazing dome of the telescope. The dome's steel structure was made in base camp below the mountain in different parts. After that, these remote-controlled trucks were used to transport these parts to the top of the mountain, which would one by one transport the steel frame to the top of the mountain. After reaching the top, the cranes joined these terrifying structures together as if they were joined together by a Lego. To reach this part of the Atacama Desert, the network of roads was built to a great extent. Because another telescope of ESO is also present 20 kilometers away from the E-ELT site, which is called the Very Large Telescope, or VLT. So for E-ELT, these road networks were extended and sent to several Amazons. Behind making E-ELT the world's largest telescope is its mirror, which is 39 meters tall. For now, a structure is being built inside the dome to control this big mirror. And how big is it itself? You can guess from this worker who is standing on the frame. This 39 meters mirror is made of a total of 800 small pieces whose work is to multiply any light coming from space and reach secondary mirror M2. From M2, this light will reach M3 and then M4. M4 will make the image sharper, and for this work, strong laser beams attached to the dome will be used. These lasers are usually set at such a wavelength that excites sodium atoms in the 90-kilometer sky, which makes them shine and become an artificial star. The telescope uses this artificial star as a reference point so that in real time it can be found out how the atmosphere is distorting the light. When the distortion in the atmosphere is detected, then the blur in the image of the telescope is easily eliminated. This whole process is called adaptive optics. After the blur of the image is eliminated from M4, this light reaches M5 and the image is corrected here and sent for processing. Enough about the magnificent working of the telescope. The biggest question here is, what will we get through E-ELT? E-ELT will be the only telescope that can take a direct photograph of exoplanets outside our solar system. Those planets that are afraid of the impact of life. For now, these exoplanets can be indirectly seen by other telescopes. Only when they pass in front of their star, their shadow is visible. Through direct photography, we can know how the atmosphere is on those planets, and from the atmosphere we can know whether there is water or not, carbon dioxide or oxygen, or if there is any creature that is producing pollution like the Earth. Because of the big E-ELT's mirror, a lot of light can be accumulated in it, and through it, we can see the beginning days of the universe. If you don't know, then keep telling yourself that light has a fixed speed and it can't travel faster than that. Taking advantage of this, we can easily see the past of the universe. A simple example of this is the first ray of our sun. When the sun rises every day, we are actually seeing the past of the sun, because the sun's light takes about 8 minutes to reach the world. Hubble Space Telescope can see 1,340 crore years back in the universe. That means its mirror captures the slow light that was 1,340 crore years ago in the universe and has reached Hubble today. On the other hand, the 39 meters big mirror of E-ELT is also capable of seeing the light 10 crore years back from Hubble telescope. That means 1,350 crore light years away. According to scientists, Big Bang, which made our universe, happened 1,380 crore years ago. This means that E-ELT can capture the view of the universe 30 crore years after its birth. Here you also need to know that E-ELT is undoubtedly very big, but it is the biggest telescope built on mirrors. Whereas radio telescopes have a huge dish like the one in the Golden Eye. Instead of mirrors, these telescopes are seen through radio waves in the past, and then their images are made through computerized processes. But looking directly, E-ELT is still the world's largest telescope. Talking about the cost of this, E-ELT has been estimated at a staggering $160 crore, 136 billion. This is almost the same cost as the world's tallest building, Burj Khalifa, was built. According to experts, the construction of E-ELT will be completed in 2029. After getting fully ready, maybe they can answer the biggest question. Are we really alone in this universe, or is life also settled on a planet like Earth, thousands of light years away? I hope you will like and share this video. Thank you so much for your loving comments. See you in the next video.